And now finally for the hybrid scenario with the Couette-Poiseuille flow, we're going to go ahead and use the same length and the same height that we used previously for Couette flow, so 250 millimeters long and 5 millimeters high. And once we open the setup here, we're going to assign some different boundary conditions. Well, first we're going to make sure that our air density and viscosity are what we want it to be, as well as our model being. Alright, so now we're going to make sure that it is laminar. Once again, we're going to go through these check boxes. This is going to be that. And now we're going to move on to our air. Make this density 1, make this density 3 again. I found that this works best to try to get our Reynolds number as low as possible. So now moving on to our boundary conditions, our inlet is actually going to have a velocity as well as our upper wall, since that is what this hybrid flow is. So we're going to make sure our lower wall is stationary and it has no slip, and we're going to make sure our outlet is a pressure outlet and we prevent reverse flow. And for our upper wall, we're going to make it a moving wall with a speed of also 0.5 meters per second. And with that being set in place, we're going to go ahead and initialize our run and our simulation. And once that is complete, we're going to run 200 iterations and go ahead and calculate that. So now that that's done, we're going to go ahead and go back to our workbench, and we're going to open up our results now to set up the velocity profile and our contour with the velocity vectors. So now that I'm inside of the results, I'm going to go ahead and create our lines. So same thing as before. Our midline is going to be at 0.125, and our height will be 5 centimeters. We'll make 100 samples. And now for our end line, it's the same thing but with new values. Same height, also 100 samples. And now our developing flow, let's make it very small. And let's make 5 centimeter height. Go ahead and apply that. Change our view. Okay. Now we make our contour, the symmetry plane with our velocity, 110 contours to make sure that it's fine. Everything else should be good. Go ahead and apply that, and now we would see our velocity contours, which is about where we want it to be. And now we put in the graph, which will be our velocity profile for Couette-Poiseuille flow. We're going to input the data that we want to get and their respective names. And go ahead, change the x-axis and our y-axis once again to our velocity and height respectively, and go ahead and apply that. And yeah, this we will see our developing flow looks very turbulent here because it's very small, or sorry, very close to the edge that we are inputting that pressure gradient. So if we make that a little bigger, sorry, a little farther along, we're gonna go ahead and see that it starts to become fully developed like our midline and end lines. And I think that's it for our hybrid Couette-Poiseuille flow. Again, here's the velocity profile, and here is the velocity contour.